Definability, solved problems. First problem. Find the set defined by the formula P1x on the below unary structure. The formula P1x defines a set of elements of the model that are in the set P1m. In other words, the formula P1x defines a set P1m. Next problem. Find the set defined by the formula P0x or P1x on the below unary structure. The formula P0x or P1x defines the set of elements of the model that are in the set P0m or in the set P1m. In other words, the formula P0x or P1x defines the set P0m union P1m. Find the set defined by the formula P0x and P1x on the below unary structure. The formula P0x and P1x defines a set of elements of the model that are in the set P0m and in the set P1m. In other words, the set of elements that are in the intersection P0m intersection with P1m. Find the set defined by the formula P0x implies P1x on the below unary structure. The formula P0x implies P1x defines the set of elements of the model that are either not in the set P0m or else are in the set P1m. In other words, the formula P0x implies P1x defines the set which is a union of the complement of P0m and P1m. Next problem. Describe the ordered structure of the reals with 0. So we should consider the structure M, which has as its universe the set of real numbers R. It has the canonical natural order less than of the real numbers, and it has a constant 0. We can think of the vocabulary as consisting of R0 and C, where R0 is a binary relation symbol for the order and C is a constant symbol for 0. So the interpretation of R0 in M, the relation R0M, is a set of pairs A, B such that A is less than B in the usual order of the real numbers. And the interpretation of the constant symbol C is 0. So as a picture, we can think of the reals as a line and 0 in the middle. It is noteworthy that although we know all the real numbers 1, minus 1, 1 half, pi, square root of 2, minus square root of 2, and so forth, we don't have names for those in this structure. So this is like a very poor version of the real numbers. We just have the order and one number 0. Still, we can talk about negative numbers, positive numbers, and so forth. One can think of the importance of such a structure in the following terms. Suppose we want to communicate to someone who doesn't know about real numbers, what they are like, but at this point we only want to talk about negative numbers and positive numbers and 0. So then we explain that it is this line where there is one point, 0, and whatever is left of it we call negative, right of it we call positive. And if we have 2 points there, A and B, and A is to the left of B, then we say A is less than B. So we leave everything else out. We don't talk about plus and times and such things. An extreme anecdotal example would be that if we were communicating with some hypothetical alien power in a nearby star, and we would have no means to actually show what we mean by like drawing pictures or showing with our hands or pointing, then we would ask those aliens to draw a line and put the point in the middle, and then we would say, let's call that point 0, and let's call what is left of it negative and what is right of it positive. Mind you, the aliens might ask, what is left? What does left mean? So then we would be in some trouble, but we could just say that let's take one side of this and call it left and the other side right. And the aliens might get it wrong, but anyway, we would then get a kind of symmetric image of the real numbers. Next problem. Describe the ordered structure of the real numbers with 0 and 1. Aha. Now we have a little bit more. We have two constants. So the model has a universe R, it has a binary relation less than, and it has two constants 0 and 1. So the vocabulary consists of one binary predicate R0, two constant symbols C and D, for example. They could be E and F also, but let's call them C and D. The interpretation of R0M is a set of pairs A, B such that A is less than B. The interpretation of C, Cm is 0, and the interpretation of D, Dm is 1. So now we have a little bit richer picture of the reals, but still it is far from what we know about the real numbers. There's no addition, no multiplication, no square roots, no nothing. It's just this order and two constants. Still we can say here a few things. We can say what it means to be negative, what it means to be positive, and even what it means to be between 0 and 1. It's not much, but you can say a few things with that. Next problem. Find the sets defined by the below formulas on the structure R less than 0, 1. The first formula is x less than 0. So we are looking for the set of elements which satisfy this formula x less than 0. So here we are thinking of 0 as the constant symbol which is interpreted as 0. We could have denoted it by C, but we simply denote it by 0. The same for 1. Instead of talking about the constant symbol D, we just talk about the constant symbol 1 and decide that the interpretation of this constant symbol in the real numbers is 1. Very natural. So, let's look at the formula x less than 0. Of course, this defines the negative numbers. Then the next formula, 0 less than x and x less than 1. So this defines numbers between 0 and 1. The next formula, 1 less than x. This defines the set of numbers which are greater than 1. Finally, x less than 0 or 1 less than x. It defines numbers which are negative plus the numbers which are greater than 1. Very easy. Find the binary relation defined by the formula x greater than 0 on the structure R less than 0. Again, we use here 0 both as the real number 0 and the name for it in the vocabulary. What could be confusing in the beginning is that we are looking for a binary relation So we should have a formula with two free variables, perhaps x and y, but there is just x. That means that y can be anything. So here is a picture. We take any pair A, B, so that A satisfies the formula x greater than 0, that is A is positive, and B can be anything. Find the binary relation defined by the formula y less than 0 on the structure r less than 0. Again, we denote by 0 both the element 0 of the real numbers and the constant symbol in the vocabulary, which is interpreted as 0. Again, we want a binary relation, but we have only one free variable in the formula. It means that the other variable, x, can be anything. So it is a set of pairs A, B, so that B is less than 0 and A can be anything. Find the binary relation defined by the formula x greater than 0 and y equal to 1 on the structure r less than 0 and 1. This relation is a set of pairs A, B, so that A is positive and B is constant 1, so this is really the positive part of a line. Find the binary relation defined by the formula x less than 0 or y equal to 1 on the structure r less than 0, 1. So here we have a relation which consists of pairs A, B such that A is less than 0, A is negative, or y equals 1. So we should take the entire half plane where the x-coordinate is negative and add the line y equals 1.